Okay, we are back. Let's look at the counters we've looked at so far. We've said that if we were dealing with one, I'll change now. I'll change. I want people to be flexible with this. I want people to be keenly aware that when you are doing counters, we are dealing with what with just like when we're dealing with the shift registers, we are dealing with what D-type flip-flops. Now when we're dealing with counters, we are dealing with what with T-type. Call this. Okay, T-types. All right, T-type flip-flop. So what we do is when we say we have one flip-flop, we can only count 2 to the power of n, where n is equal to 1. So we can only count 2 counts. All right. When a counter can count only 2 counts, it's called a module. What call this? Let's say module n. What do you mean by module? As a module n means a counter can count n counts. All right. Module, this one can count 2 counts. One flip-flop can do only 2 counts, 0 and 1. So that will be a module 2 counter. Okay. So now when we add what call this more, okay, this will be what call this 2 flip-flops can count what? That doesn't mean it will, but it means it can count what? 2 flip-flops can count what? Can count 2 to the power of 2, which is what? Which is 4. It's a module 4 counter. Okay, if it can count 4 counts, if it's allowed to count 4 counts, then it's a module. Something is wrong with my instruments. Why? Oh, okay, nothing wrong. Wrong rubber. Okay, so when it can count, what call this one can has the ability to count 4 counts 2 to the power of 2, therefore it will be a module what? A module 4 counter. All right. With 3 we saw it could do 8 counts. It's a module 2 to the power of 3, a module 8 counter. The last time we dealt with it was a what? We had an up down counter with 4 bits, and we said it can count from 0 to 16, 0 to 15, sorry, and also count down from what? The one could count up and down with an also a circuit there, which said where we could choose whether we are going up or down. Now, because there were 4 bits, it was a what? Module 16 counter, 2 to the power of 4, which is 16. All right. So now, so we are aware, our flip-flops are what? Are T-type flip-flops. That's how we do our counters. All right. But suppose we used a different type of flip-flop, like the JK flip-flop. What we didn't do previously, before I do that, what we didn't do previously is that we didn't release what about the set and reset as such. All right. When you are going to count up, we are going to what? To have the ability to what? To reset our counter. So we are going to have a what? A reset data input. Okay. We are going to have reset data inputs. All right. If you are going to count up, if you are going to count down, sorry, it means we have to have what? These are what? Our reset data. So if it's a countdown, if it's a count up, we know that it's taking from the queue and fitting the clocks from the what? From the queue. Only the first one is run by the master clock. So count and an up counter would have that. All right, and then it would have the outputs, the clocks being run by the outputs. All right. A down counter, however, is the other way around. What do you do with the down counter? The down counter is the other way around. We do not have, we do not use the queues. Rather, we use the what? The not queues. All right. But then again, now it won't make sense for us to what? For us to reset data. We'll then have to what? We'll then have to, for down counters, we'll have to use what? The set. So that when you set, the count goes to the maximum, and then the what? The counter goes to the maximum, and then the what? And then the counter can now count down. Okay, so we should not forget that there is a what? set data and reset data for these counters, and we still set and reset with what? With ones and zeros. Now a down counter will count from will clock from the main clock, the first one, and then the rest will clock from the what? From the not queues. All right. So, however, I want to do one what I'll call the module 10 counter. An example is module 10. Our example is going to be module 10. I'll call it the decade counter. It counts 10 counts. It's the decade counter. What does it do? It's a decimal counter. It counts from 0 up to what? 0 up to 9. All right. So how does it differ? It's okay. We'll take it as an up counter. We'll start with the up counter. With the up counter, we will not be resetting. We will not be setting. We'll be resetting. Okay. So our counter is counting up. Therefore, what happens is that the very first one. Now with this one here, that's why I said the counts. Our counters should be what? We should use what we call the what? The T-type flip-flops. But any other one that can be set as T-type will work. Okay. For our ticket counter, in fact, in the other instances where we're using what? Where we're using T-types, it could have been JKs, as long as you remember that JKs that are either configured with 1 1 1 1 1 1. Remember that JK is with 1 1. What is it? Let's go back to the truth table of the JK. If we have the JK flip flop, there is the truth table 0 0 0 1 1 0 and 1 1. We know that the Q and not Q, what do they do? Here nothing changes. They stay as they are. However, if they are different, the Q follows the what? The J. So this is where when they are different, they behave like a D-type. We say the JK behaves like a D-type. We say here it just memorizes. And then we say here there's what we call what? The not Q status jumps to Q, and the Q status jumps to what? To not Q. And you say this is what we call the toggling state. Okay. So if we wire 1 1 on the JK, it behaves like a what? Like a T-type flip-flop. So we can use our what? With our counters, we can use our T-type flip-flops, or we can indeed use JKs as long as they are configured as what? As long as they are configured as what? As T-type. So we could have our what? Our up counter using JKs, and that would work very well because this is more or less our what? This is our JK working as a T-type. So this would count up. Remember that our counts are always taken from the what? From the output queues. That would be our Q1, that would be our Q2, that would be our Q4, that would be our Q8. So yes, this will work perfectly. Alright. But this can count from what? From 0 0, from Q8, Q4, Q2, Q1, 0 0 0 0, count up all the way to 1 1 1 1, which is what? 0, the count 0 to 15, and in total that's 16 counts. This is therefore a module 16. This is a module 16 counter. Okay, so this is just a reminder that yes, we, as much as it's our T-types, but sometimes what? Sometimes we can use JKs and they will function very well. However, there are certain specific what call this counters, like the module 10 counter. It will really need you to have what? To have JKs. You can mix JKs and what? And JKs, but for speed and other characteristics, it's not advisable to mix them. All right, but if everything else matches, it's not criminal. You can still do it. Now let's have the ticket counter. This counter here has a problem that it can count from 0 all the way up to 15. With the ticket counter, we want to go only as far as 9, because that is our decimal. So we only want to go as far as what? As far as 9. So let's let the first one be a what? Be a what call? Be a normal T-type, or a JK configured as a T-type. The next one the next flip-flop here, we have it actually feed both the clock and, so this one here will not work as a T-type. We'll have it feed both the clock and. So what you see here is that our J and our clock are fed from what? Are fed from, let's go, from our Q. Alright, then what happens is that if you look at the next one also, this one here feeds, we let this one feed the J. Oh, okay, let me rather remove that. We have this feed the J, okay, but our clock now, the first clock here comes and feeds the last one. Okay, so that, and then here, this one here, as much as it fed this, it also goes to feed this. What do you mean here? It means we'll have J1 and J2. So we have two inputs. It simply means a what? It simply means an AND gate. Okay, let's then take that one there and take it back to feed that. What do we have here? Let's double check. The first one feeds the output feeds the clock and the last clock. Okay, so it feeds the second clock and the last clock. Our second one feeds the J and the clock, but it also feeds the next J. Okay, and then the third one, it feeds the what? It feeds the next J. Now what do we then have? And we have the NOT Q being fed back to what? To the Q. But this one here remains our what? It could even be replaced by what? You can see that these ones don't necessarily work as what? As a T-type anymore. Okay, they are now really specifically JK. Now let's see now what happens if we do this. Let's have, I will be slow because this shape is a little bit of a problem. Let's have about 11. I want 10. I'm not sure where I am now. 1, 2, 3, 4. 5, 6. This is our clock. 7, 8, 9. I'm opening it a little bit too wide. 10. Let me have 11th one just to see, because I want 10 counts. This is the clock. Okay, I'm gonna mark our trailing edges where the response is are going to take place. I'm marking there. I wish there's software that was a little bit faster. Probably this is fast. Probably I'm not as good at it as I want to believe I am. Okay, I'm not. Alright, let's see if I can be faster. I could just copy and paste these things, but I hope if people are not bored, I hope doing it together makes people really keenly aware of what we are trying to do. I hope it involves people to actually do it in real time. Now, What you then have is, obviously, if it's a decade counter, it's counting up, so we are going to have a reset. And now our reset has to be marked as well. So now, if we have Q1, we have Q2, we have Q4, and we have Q8. Let's suppose we're at the count 7, 0, 1, 1, and 1. Reset would say everything goes to 0. What was 0 stays 0. Alright, so that we have our initial count as 0, 0, 0. Let's observe now. Let me make this clear. Let's observe now with 0, 0, 0, 0. Let's observe what happens here. With the next clock pulse, with each clock pulse, this is the main clock, so the main clock comes only here. Alright, so this one will keep toggling. We know a JK set to 1, 1, all it ever does is toggle with each trailing edge of the clock. Leading edge we pass, trailing edge we toggle. Leading edge we pass, trailing edge we toggle. Leading edge we pass, trailing edge we toggle. And so on and so forth. Oh. Oh. Alright, I'll ignore that. Yeah, so this one, Q1, will only be toggling because this is set to T type. So every time there's a trailing edge, this will toggle. Now, what we then see is this is driving that clock. The output of that is driving that clock and that clock. So what do we expect now? We expect that when there's a trailing edge, we have to observe what's being fed back, what's being fed to each and every one of them. This is a 0, so a 1 is being fed here. So he is going to toggle as long as we have 0 on Q8. Okay, it will be a 1 there, so it will be 1, 1. That is not connected. So every time there's a 1 there, this will also toggle. So from the count, as long as we have a 0 on 8, this will toggle. So let's go to Q2 and say, as long as there's a 0 on 8, that one will toggle. So that is the time when that one toggles where the feed is Q1. When Q1 is what? Is going from 1 to 0, which is our trailing edge. So it's here. So Q2 will toggle there. Okay. This is the leading edge, so nothing will happen with the leading edge. We'll check. So now what do we have? We have 1, 0. Let's just feed this through so that people can see what we are talking about. This was always talking, so it's 1, 0, 1, 0. So this is 1, 1 so far. So obviously, for this one to toggle, we have to also see a what? A change from what? From Q2 from 1 to 0, which is trailing edge. Let's see. 0 to 0, no. This is 0 to 1, that's leading edge, no. 0 to 1, that's leading edge, no. Okay, so now let's see. Here, Q8 is looking at Q4, and however, this here is being driven by what? Is being driven by Q1, the time of Q1. So we have to look at what happens here, what happens there at the trailing edges of Q1. What happens there? What happens here? What happens? I'm looking at Q1 changing from 1 to 0. I'm looking at Q1 changing from 1 to 0, which is the trailing edge. So I'm looking at 1 to 0. I'm looking at what happens there. All right. So nothing will happen all the way up to here. So we have got 0, 0, 0, 0, 0, 1. Okay. So from there, this stayed 0. So there is even though there is on Q1 there's a trailing edge there, what's happening here is that, where are we? We are at the count 0, 0, 1. We have a 1 here. We have a 1 there. Okay. Q1 is a 1. Now the Q1 changes to a 0. But at that point there, that there was what? Was Q1. Q1, that's a trailing edge. So this is a trailing edge 0, 2, trailing edge. It's 1, 2, 0. 1, 2, 0. We expect a response. Let's see. But here, what did we have? We are at 0, 0, 0. So everything is 0, 0 there. So what happens there is that we have a Q of, so that's a 0. So this is 0, 1. So it's going to fit a 0 to Q8. So Q8 is going to be a 0. Okay. Now, when you come here, Q1 is leading, so nothing will happen here. Alright. So now, you have up to the count 0, 1, 1. So what do we have here? We have 0, 1, 1. Now, if we have 1, 1, we've got a 1 there. We've got a 1 here. We've got a 0 here. So this is going to be first 0. So Q8 is going to continue as a 0. So for now, when you get a trailing edge, this here is a trailing edge for Q1. Now, what's waiting is 0, 1, 1. So what's happening here is that this here is 1, 1. This is going to what? This is going to, Q4 is going to toggle because it's seeing 1 and 1. So Q4 is going to toggle. Q4 is going to toggle. Q2, on the other hand, it was being fed a 1, so it's going to toggle. Q2 is going to toggle. This is 0. Now, what about what happens here? What happens here is Q8 is seeing yes, Q1 changed to 1 to 0, but so this is 1 to 0, so it's a what? It's a trailing edge, but what data is being given there, it's a 1 and a 0, so it's still a 0, so a Q8 is going to be fed as 0. So what does that mean? It means Q8 is fed as 0. So don't we have the count 0, 1, 2, 3? Now we're at 4. Now what we're seeing here is a leading edge. So that does not respond to a leading edge. That does not respond to a leading edge. That is a leading edge. Q8 does not respond to a leading edge. Okay, so that is the count 5. Next count, that one there. This is a what? A trailing edge. What happens here? Let's first fit the counts. Let's first fit the counts to make sure that we are on the same page. We are on the count 0, 1, 0, 1. We are on the count 0, 1, 0, 1. Oh, I didn't remove that one. So this 0 here, this 0 here makes that a 1. The 1 is there. So Q2 with the next trailing edge is going to toggle because 1, 1. When it's not 1, it's like a 1. So this is going to toggle. So Q2 with a trailing edge. So Q2 sees 1, 1 and Q2 toggles. However, he sees a leading edge, does not respond. And what happens here? What happens here is that we have to check what happens with Q1. Q1 is changing from 1 to 0. Yes, that's trailing edge. But what was being fed there? It was 0, 1, 0, 1. So Q2, it was before Q2 toggled. it was before Q2 toggled, so this was 0 1 0 1, so that was a 0 being fed through. As long as this is a 1, that's a 0 being fed through, so that stays a 0. And we've got the count 6. Now this will be not as a leading edge. We know nothing happens with the leading edge, does not change, and that there is a what? Is not change, because there's no trailing edge. Only this is a trailing edge. So now we're at the count 7. Let's look at the next count 8. But now we're at the count 7. Let's come and put the count 7. Okay, with the count 7, what do we have? We have 0 1 1. Oh, I put 1 in the wrong space. 0 1 1 1, but that 0 still fits a 1 there. Q2 is going to toggle if he sees a what? A leading edge. Let's see now. What's happening here is that there is a 1 being fed there and the 1 being fed there. So Q8, if you see a leading edge, a trailing edge, is going to toggle. Q1, Q2 is seeing a 1 being fed back. Q2 toggles. This is a trailing edge, so Q2 toggles. Okay, now Q2 is moving from 1 to 0, 1 to 0, but Q2 was, before it was a 1 when that clock came in, so it was a 1, so 1 1, that one will toggle. Okay, now however this one here, it was 1 1 and 1, so it sees a trailing edge from Q1, remember, so it's a trailing edge from Q1. So what does it do? It toggles. Toggling from 0, it goes up to 1. And what do we have? We have answered that question. We have our count 8. Why did I remove that? We have the count 8. So with the count 8, we have 1 0 0 and 0. This is our count 8, and this is a 1. When it's not 1, it's like a 1. Now this 0 is being fed there. The moment you see a 0, you don't have to care about the other one. This 0 is being fed there, there and there. Okay, so, and we have a 0 here. All right, we have a 0 there. So now there is a 0 being fed right there. Remember, this is like a 1. When it's not white, it's like a 1. So what happens? He's always toggling, so he toggles up. When he toggles up, no one cares. He's going up. That one drives the next one. So that one was a leading edge. Q8 depends on that one there, so it doesn't change. It's a leading edge. So we had 8, now we have 9. Now let's see with the 9. This is very important. With the 9, we are changing from 0 to 1. Okay, that becomes 1. So now we have a 1 here. We are changing from 0 to 1. All right, so which means it's a leading edge. That there, Q1 is toggling. Now Q1 is fitting a what? Is fitting a 0 on that one. Okay, now Q4 is being driven by what? By Q2, and Q2, the timing for the Q2 says no change. And let's see what happens with the last one. With the last one now, we are having a change from 1 to 0. So this is the leading edge, but you are having a what? You are having a 0 waiting there, so it feeds through a 0. So everything is a 0. So after the count 9, instead of going to 10, our decade counter decided nope. As decade counters, after 9, we restart, we go to 0. So since we followed it from 0 anyway from the reset, it means going forward it's going to do whatever it's been doing here. So it's going to keep counting from 0 to 9. So these are what? This is our module 10 counter, our decade counter. All right. So there's a little correction here that this must come and fit back there, and then you can see how our decade counter will think. If someone wanted it in what? If someone wanted it in table form, obviously it doesn't take a genius to. Let me move this first. Okay. If someone wanted this in table form, all it means is that we need a table for Q8, Q4, Q2, and Q1. And it will be the count. After reset, it will be the count. I mean, I don't know how can count up to 10. This really is as easy as it gets. This will be, all you are doing is rewriting this. This will be the count for. So someone asks you to do a table for this. They're asking you if you can count in binary, if you can count up to 9, from 0 up to 9 in binary. So that will be very rich to not be able to. That will be after the count 8, we have the count 9, but with the decade counter, it starts back at 0. Okay, this is the restart. Okay, so if you're asked to do this in what? If you're asked to do this in what? Remember what I've been trying to explain. Everything we've been doing so far, we have been using T-type flip-flops because that's what these are. Okay, counters are basically T-type flip-flops, so we've been using them, but we can also use JKs configured as what? As T-types. All right, and then otherwise, with this particular module 10 counter, you actually need to use a what? Yes, you could have a T-type for the first one, all right, but then the rest of it has to be JKs because there are some functions here that the T-type does not allow. For instance, having a 0, 1 can only be done with the what? With the JK. It cannot be done with the what? With the T-type. All right. So I hope that was not complex. I'm trying to make them as easy as I can, but obviously not using first language. It might come out a little bit more complex than it ought to be. All right then, let's see if we can do further counters later.